When we raise these frames, there's a tendency for the frame to want to shift forwards on this padstone, and as we're pulling from the top, winching it up, these dig in, and often these padstones will try and slide. So that's why we put these 2 steel pins in each side, and they actually stop the padstone from sliding, and it helps to get these feet to bed down onto the stone and for the whole frame to raise up. We also have the tourniquet ropes tied back to the post at the back there, and these tourniquet ropes we can tighten with a peg, and they'll also restrict the frames from sliding this way. Yeah, go one more, that'd be good.
Come on.
Yes. Very good. These temporary supports here, they have a V cut into them, and these we've put in to get the angle of the frame up a bit before we start the raise. The hardest bit is getting a frame from horizontal up to about 60 degrees. When it's at about 60 degrees, it starts to raise really easily. So by getting maybe 30 degrees of that lift done manually on a couple of small tripods and then getting a support underneath, it just improves the whole ease and flow of how we raise the frames. So these are in here temporarily. As the frame goes up, they will just drop away. And there's 4 ropes attached to each frame, and they form the front and back lines. So they're a bit like giant guy ropes, as if you were anchoring a tent. And one person will be on every rope, and they'll then secure these either to pegs driven in the ground, or posts driven in the ground rather, or else to trees to get a really good anchor point. And because once this first frame is up, and we've got these ropes on, the ropes will be the only thing supporting it until we get the next frame up, when we'll put temporary bracing in between them. We weren't blessed with the weather for the frame raising day. In fact, it's the wettest frame raising I've ever done. But however, it all went pretty smoothly considering that. Okay, good and steady, she's coming up. Poles are a bit slippery, and certainly if you've got more choice in your timetable to choose a better day, then I'd recommend that. The actual raising day it's quite a military operation. Everyone has key roles they have to play. They have to stay very focused right the way through the raise. Frame raising with these roundwood frames has come a bit of a tradition with us. It feels very much part of the celebration of having put the work in, worked from the felled tree through to the finished frame, and it's kind of the celebratory moment to pull up these frames in a day. It's a very focused day, and by the end of it you see the fruits of the last few weeks' work come into being as the whole building is standing. You can really start to see the structure. But at this stage now, all the main frames are up and we're moving on to fixing the wall plates, tenons on top of the jowl posts, and I can kind of see the actual formation of the roof not that far away now.
The most difficult part so far probably was the frame raising, just because of the weather, but it all went smoothly. And seeing your sort of work go up, being raised on the day, and that's just what it's all about. That's the reason why you do it. Well, what I hope to do is sort of take the skills back to the area where I'm from and see how it goes and sort of try and promote roundwood timber framing as much as possible within the area that I am, because obviously the whole point of it is it's a localised business with only a certain working radius.
With many roundwood buildings, we don't actually use any form of fixing to hold the building down. We use the natural weight of the building just to sit there comfortably on the pad stones. But the nature of this building is that it's going to have quite a big roof, and it's going to be open at one end and two sides, so there's a big opportunity of the wind coming through and gathering under the roof at the far end of the building. So I want to make sure that it doesn't work at all as a sail and try and lift up. So the way we compensate that is to actually fire 4 earth anchors into the ground. Now these are a steel anchor that we hit in with a jackhammer, and we knock them in about 3 to 4 metres into the ground. The anchor has a stainless steel cable on the end, and there'll be a rigging screw in here, and then it will be looped round the crux, and that will secure the frame down into the ground. And we'll do that in 4 positions on 2 of the separate frames. So we've got like 4 corners of the building all supported internally. The anchors, of course, will be disappeared into the ground, and all you'll actually see will be just the loop of cable and a rigging screw, and that will of course be underneath the building, under the floor. So it's not something that's visible, but it's an important part of making sure that this stays stable in high winds. One of the reasons we use earth anchors is because it avoids using any form of concrete to anchor the building down. Using just the natural weight of the subsoil, by being able to get the anchor deep into the ground below the subsoil, makes a very good fixing point and just uses the natural weight of the earth to hold the building in place. And we then tension up that cable, and as we tension it up, the anchor turns in the subsoil, and so you're actually pulling against the weight of all the subsoil on top of it. So it's not dissimilar to the process of a ship's anchor out at sea. Once we take up the tension on that and we can put a load of say 5 tons on it, we will then use a turnbuckle or rigging screw and put a loop around the crux. This is the compost toilet at Prickly Nut Wood. It was built by myself and volunteers who've been staying here, and I think it has one of the best views of toilets in the country. The split chestnut lath that we've used here to make the panel walls is the same split lath that were used in the woodland house to make the earth plaster walls. And also on the gable end of Lodsworth Larder we used it to add the lime plaster to. So this is the basic ingredient made out of coppice wood for forming the walls in these buildings. Being split or riven, it has a rough finish, which is what makes it so good for getting a plaster to adhere to. I also just quite like the look of it in its raw form like this, as it lets in a nice dappled light into the interior. So this is the ridge pole. On this build it's made in 3 sections. There's the main middle section, which is a straight ridge, and then we've put on these 2 curved sections to create the profile of the roof. The ridge pole on this building is quite unusual because we've got the main section, which is a straight ridge, and then we're dropping away with 2 curves to form the shape of the roof. And we've put a bridle joint in here. This is where you have one long tenon for a big deep open mortise, and then it's pegged through in 2 places. Some pegs here. This will be trimmed off, and this will form the actual curved shape of our roof. The other thing is these, what I call the horns of the crux. These will also end up being trimmed off all the way along the ridge, so they're at a uniform height, and the roof rafters can attach into the top of the ridge pole. As it works its way down between the crux, it's pegged into both crux, and then dips away to form the final curve at the bottom of the roof. We'll then mirror this curved shape with the rafters which we've been steam bending to create a sort of curved, oval, almost sort of turtle shell roof over the top of the building. We're steam bending the roof rafters here. What that involves is boiling up a big amount of water to create steam. We run that steam through a laundry pipe. The process of steaming involves saturating the fibres of the wood with steam so that it becomes flexible. A bit like a piece of spaghetti when it's dry. You boil it in water and it suddenly becomes bendy. Once it dries out again, it becomes solid. The same with steam bending. You saturate the fibres with steam, bend the piece of wood over some form of jig that shapes it, clamp it in position, and then as it cools it sets in that position. This is a little experimental from the point of view that Lawson Cyprus is not well known for its steam bending, but I don't know of people who have bent it in the round. Most steam bending is done for boat building or chair making, and it tends to be done with sawn or cleft pieces of wood. In the round, because the fibres are all intact within the piece of wood, there's a lot more possibility of bending it without the wood buckling or splitting out. And we're actually only going for a gentle bend just to create a nice curve in the roof shape. And so far it's going really well. The roof rafter is fitted into the gas pipe, and then we've packed it with clay around the outside, and we steam each one of these for about 3 hours of intensive steam, and then take them out of the pipe and take them over to our jig, where we sit upon the actual rafter to weigh it down and then ratchet it in position.